Hello, welcome back to the next segment of our lesson. Now we are going to look at the negative binomial random variable. First of all, let us consider two similar probability problems. Problem A. Find the probability that David shoots a basketball through a hoop 3 times in 4 attempts, given that the probability that he will succeed each attempt is 0.25. Problem B. Find the probability that David shoots a basketball through a hoop the 3rd time on the 4th attempt, given that the probability he will succeed each attempt is 0.25. In what ways do these two problems differ? In problem A, the random variable x is the number of successes in 4 attempts, and x can take values ranging from 0 to 4. In this particular case, we are looking for p x equals to 3. In problem B, however, we are looking for the 3rd success, and x is the number of trials that will give you the 3rd success. So x here will be equals to 3, 4, 5, and so on. And in this particular problem, we are looking for px equal to 4, meaning that we want to have the 3rd success on the 4th attempt. Another difference is, in problem A, the 3 successes required can happen in any of the 4 attempts. You have 4 attempts, and we want 3 successes. For example, we can have success on the 1st attempt, on the 3rd attempt, as well as the 4th attempt. In problem B, however, we must have a success on the 4th attempt, meaning we must have success here, and we can have any 2 successes in the previous 3. For example, we could have on the 1st, on the 2nd, and not on the 3rd, or the 1st, not on the 2nd, or the 3rd, or just simply on the 2nd and the 3rd. But we must have success on the 4th for all 3 cases. So, we can tell that problem A is simply a case of the binomial distribution. We have x binomial 4, 0.25, and we know this distribution. Cases such as problem B are new to us, and it is called the negative binomial. Negative binomial. Let us explore problem B further. Let x be the random variable representing the number of attempts achieve the third success. In this case, shooting the basketball through the hoop. So as you can see, x cannot be less than 3 because we need 3 successes, and if x equals to 2, for example, we cannot get 3 successes. Let us just call the probability of success P for now. Probability of success. So the probability that x equals to 3 will be simply P here, and we must have P and P here on the first 2 attempts to get 3 successes. To get Px equal to 4, we must have a success on the 4th, and we need a success on the first 2. So we have 3 C2 ways of getting 2 successes, which is simply a binomial. And the probability is given by 3C2 P squared Q times P. To find the probability that x equals to 5, we will have 2, 3, 4, and we need a success on the 5th, and we need 4. So there's 4 C2 ways of getting 2 successes. And there is another binomial, so the probability of x equals to 5 is just 4 C2 times P squared Q squared times P. And so we can observe some patterns here. For example, when x equals to 4, we have the NCR, the n, to be 3, which is 1 less than 4. For x equals to 5, we have n equals to 4, which is 1 less than 5. We also note that the power of p is 2, regardless of the value of x. And the powers of p and q sum up to n. So for the case of px equals to 4, we have 2 plus 1 equals to 3, and for x equals to 5, 2 plus 2 equals to 4. Therefore, if we want px equals to 6, we can observe that this should be 5 C2 P squared and Q3 times P. So in the case of Px equals to 3, we will get 2C2 P squared and Q0 times P. And this gives us PQ, which is what we have observed earlier. So turning to the next page, we are now in a good position to generalize the PDF of a negative binomial. So for our successors, we will have Px equals to x will be equals to, you will have the last one here, the x will be a success, and we will have x minus 1 previous attempts, and we want r minus 1 successes. So we will get a binomial, so it's x minus 1 cr minus 1 p r minus 1 q x minus 1 minus r minus 1 times p. And we can simplify these to x minus 1, choose r minus 1, p r, so you multiply p to the power of r minus 1 times p, and that is multiplied by q to the power of x minus r, where q is equal to 1 minus p. Note that the valid values of x will be starting from r plus 1, r plus 2, and so on. So in IB, the notation for negative binomial is given as x is a random variable, and you have NB for negative binomial, and open a bracket, number of successes that you want, and the probability of success. Note that there is no Ti NSpire inbuilt PDF and CDF functions. Right? But we know that Px equals to x will be simply a binomial in the x minus 1 trials times p, and we need r minus 1 successors, which is a binomial. So we improvise, and we have Px equals to x as a binom PDF, which is the standard binomial function on your Ti NSpire. We have n to be x minus 1, and the probability of success p, and we want r minus 1 successes times p, where p here is the r success on the x attempt, and here the binomial is simply r minus 1 successes in any of the previous x minus 1 attempts. For a CDF function, for example, we want Px less than or equals to x, we can use this particular function. We have x starting from r to the value of x, and we have the same binomial PDF So now let us use technology in order to solve the same question. So for part A, find the probability that David shoots a basketball through a hoop the third time on the fourth attempt, given that the probability he will succeed each attempt is 0.25. So we have x, a negative binomial random variable with probability of success 0.25, and the number of successes required is 3. So we want p x equals to 4, and that is equals to 3c2.25 squared times 0.75 times 0.25. This is equals to binom PDF 3, 0.25, 2 times 0.25. And that is our part A. And the answer we will find using a graphic calculator. So we type in carefully binom PDF and we put in 3, comma 0.25, comma 2 times 0.25, and the answer is 0.035156, and we can reduce this to 0.0352 as F. In part B, find the probability that he will need at least 4 attempts and no more than 8 attempts to shoot through the hoop the third time. So we have P at least 4, so we want 4, and then we have the X here, and no more than 8. So this is actually the sum. We have X equals to 4 to 8. We have put in again the binom PDF, and we have 3. We have like x minus 1, comma 0.25. We need 2 successes before and times 0.25. And we get 0.305832. Now I am going to teach you how to find the mode of a negative binomial. We will use a graphical method to find the mode. We will plot binom PDF x minus 1, comma 1/3, comma 2 times 1/3, and use a split table to find the highest probability that will give you the mode. Watch the following video. So we plot binom PDF x minus 1, 1/3, 2 times 1/3. But you won't get a graph because the data is discrete. So we choose split screen and scroll through the values of probability that will give us the highest probability. Since 0.109739 is the highest, therefore x equals to 6 and x equals to 7 are the modes because they share the same highest probability of 0.109739. So let's just show that the negative binomial random variable is a sum of geometric random variables. Let's just consider the example that we have. Y is a negative binomial random variable with successes equals to 3 and the probability of success equals to 1/3. Let P equals to 1/3 and Q will therefore be 1 minus 1/3 equals to 2/3. Because we want 3 successes, let Y equals to x1 plus x2 plus x3, where each x is a geometric with probability of success P. So we can actually examine this problem a little closer. Suppose we want to find the probability that y equals to 4. Let us consider all the possible combinations. You have x1, x2, x3 and y. So in order to get 4, we can have 1, 1, 2, which equals to 4. So we have geometric, a success in first attempt, followed by a success in first attempt, followed by a success in second attempt. So it's a sum of 3 geometric. So you have a x1, x2 here and x3. And this gives us y equals to 4. We can have 1, 2, 1, which also equals to 4. So you could have success in first attempt, then success in second attempt, followed by success in first attempt. So again you have sum of 3 geometric. They are arranged in consecutive order, and this gives us y equals to 4 as well. Thirdly, we could have 2 plus 1 plus 1 equals to 4. In this scenario, we'll have a failure followed by success, which gives us the first geometric. Then we have success in first attempt, and then followed by success in first attempt to give us y equals to 4. So as you can see, the negative binomial is indeed a sum of consecutive geometric random variables. You can also observe that last value is always p, which is true of negative binomial as we have found earlier. You will also notice that the first 3 terms here, for all 3 cases, is a binomial, finding two successors in 3. So we can have the answer that we want, P y equals to 4 is equals to 3 C2 P squared Q power 1 times P, as we have found earlier. So for the case of y, with r successes and the probability of success p, we can write this as y equals to x1 plus x2 plus all the way up to xr for our number of successes. And from expectation algebra, ey will be equals to e of x1 plus x2 all the way to plus xr. And this is equals to e of x1 plus e of x2 plus and so on plus e of xr. And we know that ex is equals to 1 over p for a geometric. And so ey is just simply r times 1 over p, which is r over p. So the mean of a negative binomial random variable is equal to r over p. Its variance is similarly variance of x1 plus x2 and so on up to xr, and since x1, x2 all the way to xr are independent of random variables, we therefore have variance of y equals to variance of x1 plus variance of x2 and so on, plus the last term variance of xr. And we know that variance of x for geometric is equals to q over p squared. Therefore, the variance of a negative binomial is given by rq over p squared. Let us finish off this lesson with an example that is taken from the May 2013 option paper. The question goes like this: when Ben shoots an arrow, he hits the target with probability 0.4. Successive shots are independent. In part A, I, find the probability that he hits the target exactly 4 times in his first 8 shots. So in this case here, x is a binomial with n equals to 8 and probability of success 0.4. Therefore, p x equals to 4 will be equals to 8 C4 0.4 to the power 4 times 0.6 to the power 4. And we can use our graphic calculator to solve for this. And in the calculator, you will use binom PDF 8, 0.4, 4. So working out the answer, choose probability, look for distributions, and look for binomial PDF. Equals to, you put in n equals to 8 and p equals to 0.4. and you get 0.23243 approximately equals to 0.232 in 3 significant figures. In part 2, we have x here, a negative binomial with successes equals to 4 and the probability of success 0.4. So we have p x equals to 8 here will be equals to binom PDF. We have 7 previous attempt, 7 comma 0.4. We want 4 successes altogether, so we have 3 successes previously and times 0.4 here, and we get 0.116122 approximately equals to 0.116 SF. In part B, we have another negative binomial problem. We have B part 1. We have x here is negative binomial with r equals to 10 and the probability of success equals to 0.4. In this particular problem, E of x formula is r over p, so this gives us 10 divided by 0.4, so that gives us 25. In B part 2, we are supposed to show that p x equals to x divided by p x equals to x minus 1 is equals to 3x minus 1 divided by 5x minus 10. We know that p x equals to x is equals to x minus 1, so that's r minus 1, so that's 9, then you get 0.4 to the power of 10 times 0.6 to the power of x minus 10. This simplify to x minus 1 factorial over x minus 10 factorial 9 factorial times 0.4 to the power 10 times 0.6 power x minus 10. You also have p x equals to x minus 1 equals to x minus 2 factorial over x minus 11 factorial 9 factorial times 0.4 to the power of 10 times 0.6 to the power of x minus 11. Therefore, we have p x equals to x over p x equals to x minus 1 equal to x minus 1 factorial divided by x minus 10 factorial 9 factorial times x minus 11 factorial 9 factorial divided by x minus 2 factorial times 0.6 to the power of x minus 10 minus x minus 11, and that can be simplified to be x minus 1 over x minus 10 times 0.6, and that is equal to x minus 1 over x minus 10 times 3 over 5, and we get 3 times x minus 1 divided by 5x minus 10, which is what we are supposed to show. For the last part, which is B part 3, we are supposed to find the mode. To find the mode. So we look for Px equals to x over Px equals to x minus 1 to be greater than 1. So what we have is 3x minus 1 over 5x minus 10 greater than 1, and we have 3x minus 3 greater than 5x minus 50. We have 2x less than 47, or x is less than 23.5. So as x has to be an integer, the mode is equals to 23, and we can verify this with the use of a graphic calculator. So we key in the function binom PDF x minus 1 0.4 for the probability of success, and 9 successes, followed by 0.4 for the 10th success, and you will now split screen and scroll down to find the highest probability. As you scroll down, you will find that 23 gives you the highest probability.